Hi and welcome. This time around we'll be making a print nozzle for a 3D printer for a friend of mine. And the crazy part about this, most of it's very straightforward and simple, but there is one particular part that is going to be extremely difficult. And the print nozzle that comes standard with a 3D printer, it's a Prusa, and the nozzle that comes with it comes standard with a 0.4 millimeter orifice, which would be this portion right here. And he would like to try a smaller orifice, which they sell, and I thought, heck, I'll try and make this. Here is 0.3 millimeter right here. These are 0.3 millimeter drill bits. For reference, here is a dime. Here is the edge of a dime next to the 0.3 millimeter. Hopefully those are in focus for you. So this drawing I have here is not to scale. This is 5 times normal. This is what the part will be. In actual 1-to-1 size, and there are a couple things about it that are going to make it really difficult. One is drilling the hole, and the second is the depth of the inside hole, so that the small hole doesn't have to be very deep, because that's only about a 2 millimeter hole itself. And the material that can make this out of, I might try brass to start with just to see if I can pull it off. Ideally would be something like D2 tool steel, because apparently some of the plastics, the extrusion plastics you can use are fairly abrasive and require something like D2 tool steel that can handle the abrasive properties without wearing out quickly. Brass would not last long with some of the different plastics out there. And it might be some of the fillers in the plastics, maybe glass or something like that. Anyways, so we're going to take this drawing, we're going to head over to the lathe, and we're going to try and make this. And I think we'll give it a first go in brass, and if it's successful, we'll try it in D2 tool steel and see how that works out. All right, let's head over. So first up, we're going to take the outer dimension to the maximum dimension of the largest diameter part of the part, and that's in 0.535 inches, so I am going to put a witness mark to work to. Okay, it's actually a little shy of it to give myself some room to come back, and then I need to find my 0. That was a little aggressive. And we need to go a total of 146 thousandths in. So let's just try 50 thousandths depth of cut first. And go over and grab a mic and measure this. All right, so we're going to chamfer this corner. Rather substantial chamfer for this one, because it's the lead-in for the die that I'm going to attempt to use. All right, so we're going to try and put some 6x1 millimeter threads on here using a threading die. I thought about single pointing these, which I may still end up doing, but for now I'm trying this. It will be a lot quicker. All right, so there's the threads. I don't have anything to test that against, I don't think. I'm gonna go look for a nut, but I'm not sure I have one. I found a nut that 6x1, and that is actually a pretty decent fit. There's a little bit of slop. It's not as good as a single pointed set of threads, but it'll do. And that die actually was a threading die, so I could have closed it more, and or you may even open it up more to make the threads shallower, or close it to make them deeper. So you can actually dial it into whatever you're looking for. This section right here is going to get an 8 millimeter hex head on it. But first, we're going to very carefully drill a approximately 2 millimeter diameter hole to a very precise depth. And I will do that using my tailstock DRO, which I made in a different project. That's actually really handy because I need this to go to a depth just before it reaches my planned tip. And then I'm going to come in from the other side and drill a really tiny hole for the tip. All right, let me get the bit. All right, so we're going to speed this sucker up, at least one more stop here, and we're shooting for a depth of 0.580 on the money. So I've already zeroed it, and we're going to just gently go in. And believe it or not, this drill bit is going to be the easy one. Let's zoom in a little. I'm going to have to come out frequently to clear the flutes. And we're there. Okay, that was a success. That's the easy one. The other side is only going to have to go in about 38 thousandths, so not a lot of depth, but considering it's a 0.3 millimeter drill bit, it's going to be challenging. Alrighty, so next we're here at 0.535, and I'm going to lock the longitudinal travel, and we are going to go in Okay, we should be right there. This is far more material than I need. I'm looking for 0.168 and 0.1684. Very good. Okay, now we can part this off, and then I have to make a holder that this will thread into, and I can flip it around and we can see if we can drill the small hole. I figured I would wait to do the hex head on this part until I actually succeed in pulling off drilling that really fine hole, which I'm not sure I can do. All right, so here's the part. Rather than use some expensive material like brass for the mandrel, we're just using a piece of aluminum that's 1/2 inch rod. I mean, all my tooling remains the same, which is great. So I'm going to center drill it. Alrighty, and tap. Using a spiral flute tap that ejects the chips out the back because it's a blind hole. All right, so we're prepping to drill this. I don't have a lot of faith here. Here is the 6mm by 1mm thread nut that goes on the other side. So we are going to try and, it just makes me laugh. I'm going to try and drill this with the tailstock. I don't know if I'm going to be able to pull it off. We're going 1800 RPM, which is full speed for this lathe. And I think I'm looking at the end of the drill bit and it is spinning around. So I'm going to have to start with a center drill to make an indentation for it to follow. I'll use my smallest one. That might actually have sort of ruined the part, because I'm not sure if it can actually have an indentation on the end that may cause the plastic to spread in an unfortunate fashion. So that may have been a mistake, but we will give it a shot. So, you know, I could always leave it longer next time, then face it off so that we don't have that little cone. Wow, I think we did it. I think we actually did it. I know this guy's sloped, but I'm going to try and use it as a form tool to make my conical shape. I'm again not sure if it's going to work. Might be blowing it. Worked better than I thought. Okay, well, then we're going to head over to the mill in a 5C collet. Okie dokie. So we're just going to put our hex on this, and we need to go up 24 thousandths total, but I'm also cutting the aluminum back a little just so I have access to this. All right, there's 24. Then we will, I need to put a stump in this thing, but we're just going to flip it around. One section, tighten it down, power it up, go a little bit slower. All right, so here's the finished part, and I'd let you zoom in to see the hole in it, but it is too small to see, I think, on camera. I don't think it's going to be able to focus on it. But this is the mandrel I made for it, and since this one went so smoothly, I think I might actually try and make one out of tool steel and see how that goes. So thanks for watching. Hope you find it useful. Hope to see you next time. This was a fun project, very challenging.